This is, I grew up in Franklin County, Virginia. I don't know if Jonathan was kind of canvassing the ground here. I don't know if we have anybody from the western side of the state. If you do, raise your hand.
Well, Central Virginia,
Central.
but Smith Mountain.
Close enough. So Franklin County, Virginia is the moonshine capital of the world. It's in southwest Virginia, closer to central, but we're down here in Franklin. Again, moonshine capital of the world. There was a recent movie, Lawless. I don't know if you guys saw it. I think it's Shiloh.
Yeah.
I hope I'm
Yeah,
Oh,
it's good.
So it was a good, good movie. So I attended Franklin County Public Schools, and I also attended Franklin County High School, which is the largest west of Richmond. So as a part of that, I didn't realize at the time, but they had a lot of elective courses for folks like me. So if I want to get into engineering or auto mechanics or whatever I wanted to do, they had that there for me, and I'm thankful for it now. And also down here, I wanted to do a shameless plug for Franklin County. This is the Crooked Road. I don't know if you guys have ever been down it. It's a really cool music trail or folk trail down in southwest Virginia. It starts in Franklin County at the Harvesters Performance Center, which was an old hardcore store when I was growing up. And now they've converted it as a 300-person music venue. And they actually get some really, really cool acts and a lot of bluegrass and your 90s country hits and things like that. But yeah, it's a great little, if you have the time and you want to go out to southwest Virginia, it's a great area. So again, go back to Franklin County High School. That's where I developed, of course, my core math skills and things like that. Going back to the elective courses, they had a drafting course. So it was your classic hands-on sticking board where we had to take an object and draw it out and make it into a 3D. You had your front and side view and your isometric view and things like that. So that's where I kind of started my love for engineering. It's in that class. It's kind of neat, like I said, So I guess to get started, the meat of what we're talking about here, I wanted to talk about some of the technology that I've seen in civil engineering in probably the last 5 years that has really impacted the way that we do business. The first is on a roadway side or heavy civil side is taking a 2D plan set like structured, what you think of engineering where you're looking at plan sets and it's all very 2D on a sheet of paper. So taking that, you can kind of see this is a normal public hearing. I don't know if you guys public hearings or municipal public hearings where you just have those very bland-ish boards where there's not a lot of, it's kind of tough for folks to understand like exactly what is going on with these projects. So as a result of that, I have YouTube clips in here, so hopefully all the stuff works. But so this is the new technology that we have there. When we have a project that's very large and very controversial, we have a lot of property owners that are affected and things like that. We can put together a video like this and have it on a loop instead of having those boards where folks can, and you'll see it. We'll go through this a little bit here, but you can visualize, you can zoom in to where, if you're a property owner, or if you want to see the traffic volumes and things like that. So let's look at this real quick here.
Where is it?
This is Route 10 down between it's in Chesterfield County. Route 10 between 95 and the Amazon.
Yeah, it's like
But you can see the difference. I mean, this is really, really nice. I can stop from here. So let's say I'm this affected property owner here. I mean, and by the way, this is real life traffic data. So before this was ever put together, folks went out there, they put the annoying cables that are on the road, counting traffic. And so that's what you're seeing here. This is not just cars driving on the road. This is the actual, in 10 years or whatever, this is what you're supposed to see on that road. And that's another great thing. And it's showing, like, these trucks are going out to Amazon for the industry and things like that.
And can that be changed like 3 different times today, like desire times?
Yeah, you can run for 8 a.m., 5 p.m., or shift changes for electrical wires and things like that.
Excuse me. So, have you offered this technology to any of the TV stations? Green dots and red dots start to orange dots.
We have, because you don't, if you run, I always hear it from the older engineers, you run the software, but you really don't know what happens behind the scenes. So there's always it's always great to have that core skill behind the scenes to understand why these software programs are really good. And this is another traffic victim. And down here on the right is where that's kind of the way that the screenshot looks when you're putting this thing together. And I don't think there's any accidents on this video. It's again, come back, you can project this thing out however many years you want. And also, one thing that's kind of neat about this is you can, I know you guys don't believe that we have to do this, but we use this for, like if we have an interstate, if we're going to have a road closure on the interstate, or a lane closure on the interstate, we can predict how many miles the traffic's going to back up. And, sometimes, when we want to actually do that construction activity. And sometimes we'll run an analysis that says you're going to have an 8-mile backup on Labor Day weekend or something like that. And you have to kind of value that risk or weigh that risk if you're being out. So, but it will, a lot of times, especially on the interstate, you can predict how many miles that the traffic is going to back up.
I'm afraid we need to get this to town 12.
Alright, so this is another really cool piece. This is probably 4 years old, 4 or 5 years old from what I can tell. So in the left side you have a screenshot of what I call AutoCAD Civil 3D. And this is kind of the nuts and bolts behind that first video that we watched, where it's the actual design file behind it. So what you can do is you can take, again, this is going from the normal 2D plan set and going to 3D. So you can take that roadway alignment, create a 3D surface, and then take that information, download it into an excavator here, and those are GPS units on top. And they can, without really, a lot of skill there, they essentially just cut the excavator on, and it will, the front of it will change because it knows where it's at in relation to the surface of the drawing, and it will physically. It's amazing to watch it. It'll go and grade that site exactly the way that it's shown.
But it still has guys,
Yeah, it's still right, because we'll get, it's always the engineer and contractor are always sometimes at odds with each other. And so we'll have sometimes we'll have like a little bust in our 3D surface, and like the guys going out there driving, and the front is good screen. They always say, what's going on at this station or wherever like that. So, there's a guy driving, he knows to, if there are issues with it, he knows to kind of fix it. Because you can't be, that's one thing, you can't be at this moment in 2016, you can't be exactly correct. But we can be 90% of the way there, and that's where the operator comes in to kind of fill the gap there. there. It's kind of a mechanical room. And there are water piping and we've got some pumps in this building. I mean, all of this stuff used to be, just something that only a certain number of people could visualize in their head, but now you can literally see it on the screen. It's pretty neat. Right, here's another John can probably like this. This is, you'll probably have to help me about what this is, but it appears to be some hospital room but again, this is the same concept of, so this is what it looks like before, and you can take the rendering down and see the skeleton. So that's all the mechanical equipment, just to support rooms like that in the hospital. It's essentially spaghetti.
So do they have some with like the blueprints, inputting all that information into the computers, or do you have scanners interior in the buildings that scan around?
It's all, we take that 2D line drawing into the program, and then you can associate elevations and things like that. So it's, we never really have to, I mean, sometimes we'll go into like an existing facility, a lot of government buildings and things like that, where all you do, you have the plans, you can scan them in, and then you'll generate the line work, and then from there you can generate models like this. And you can also do like a staged phase demo of what certain things that you can take out, and then propose. I mean, you can do a different phase model, and it's just a really, really good thing.
Quick question. We're trying to prepare our students for higher education or careers. Do you see this type of technology sort of being a shift between, say, traditional trade, plumbing, electrician, carpentry, requiring fewer skills and less use of technology, and more on the engineering side, the design side, the information technology side? Are you seeing a shift there over the next 5 years, 10 years?
I mean, I think it's like for example, I think I answered your question here, but on the BIM side, I mean, you still need those folks that will go in and construct water piping and things like that.
But do they need less skills, and is it becoming less of a technology-focused job as a plumber or electrician because of technology like this?
I would say the opposite. So go back to the excavator. The guy that used to just get in the excavator and go to town. Now he's got to understand what you don't see in there. He's got that file loaded into a screen, a computer screen in there. He's got to understand what's going on with that 3D model as he goes out through the site.
But before that, I'm assuming that excavator had to have some way of knowing that this has to be at a certain elevation and I need to remove this much topsoil. They need to figure that stuff out
Yes.
without the use of anything on the screen. So are we transferring the technology that they need to know, or are we taking away from what they used to do traditionally?
I mean, I guess you could say it's going to make their job easier. So you have maybe a It's all connected. I mean, if it's anything like AECOM, I know VDOT's the same way. You're literally sitting beside the same people. So if they're seeing the images, you're giving it to the draftsman, and the architect sitting right here, and then the modeling guy, the IT guy sitting right there. So you can see it all right there. So yeah, I would say any kind of job within that process is critical. So going back to some of the disciplines that were required to make a program like this, obviously the architect, you have mechanical, electric, and plumbing engineers for all the pipe runs and the HVAC system run, fire protection engineering for piping, and then the IT specialists that are actually putting the model together. Architect. So this is kind of going back to the West Virginia example. What we can do now is we can take 3D surfaces. I don't know if you guys have used Google Maps at all, but you can take that surface, put an instance in Trevor, take that surface, or you can fly a survey, or you can have a LiDAR survey or things like that. And you can actually do an analysis. FEMA has studied many streams all over the country. And so you can go and do a real-life analysis of those downstream areas and figure out what type of flooding they're in. And that's basically what this is. So I think this is a dam break analysis. So it's kind of showing what areas would be affected as it moves down. You can see the contours of the land. So if it's darker, it's a deeper area. But and you can also the next demo that has actual aerial images on it. So, and this is really big with flood insurance and things like that.
So this is a simulation, it's not actual.
Yeah, it's a simulation.
So in regards to West Virginia, was it like a way to predict what areas were going to get hit the most?
your prediction models have improved over the last 10 years. So what do you recommend we can do as teachers in the classroom so that we can provide you with employees that help that evolution process to improve prediction models in the future at a faster rate?
Yeah, I think it's all about understanding. We've improved our models because we have better technology. So it's all about from the ground roots having a better understanding of technology and how to develop, new models and things like that. So if you're a student now, understanding all the technology that's out there, but then also I would hope like the next generation or the next group of students will understand. Right now we have the 3D model from Google Maps or something like that. Is there a way to have a more detailed analysis to work in teams, understand different personalities and things like that, develop public speaking skills to understand, especially when you're working for state governments or municipal governments, you have to defend your design. Because it's using taxpayer money, so you need to be able to effectively speak and defend